Hello everyone and welcome back to the channel. In the last video, we started our analysis of the Latrodectus malware. We reached a stage where we extracted the final payload. In this video, we will continue our analysis of the final payload. Now, 30 minutes is not nearly enough time for us to go through the analysis of the full payload. However, we reach a stage where you as a viewer are able to continue this analysis on your own as well. If you face any issues, do hit me up in the comments or on Twitter. With that, let's get started. So here I am in my virtual machine. Let us look at some of the items we will discuss in this video. We will start off with dynamic API resolution. Then we will use that for strings resolution. Then I will show you my favorite technique for breaking down the functionality of the malware, which is API pivoting and strings pivoting. Lastly, we will look at C2 extraction. So let me now open up the final payload in IDA Pro. I will drag and drop this binary on IDA Pro x64. Load resources, press OK. The analysis is complete. Before I start looking at anything in the malware, I want to make sure that everything is decompiled properly. So I will look at this command of produce C file, which will force the IDA Pro to do the decompilation of the binary. All right, so the decompilation is complete. Let us go to the exports and look at the run export. I will be using the decompiler mostly, so I will press F5 over here and we will set up the decompiler and the disassembly side by side. Here we have our first function, so let us go here. And in this function, we have another function to start with. Let us go here then. Then we have our first function call, which is this one. This does not do anything relevant to our cause. We will look at this later as well. Let us now go to the second function. If we go to our second function, let us go to this first one, 8338, and we can see immediately that we have a hash over here. All right. And if we go inside, we can see that this code is iterating through the modules loaded in the executable. So let me go back and let us look at hashdb hunt algorithm. And it says that this algorithm has been detected as CRC32. So I'll press OK here, right click hashdb lookup. And it says that the hash is found and this is kernel 32 and it has been added in the enums. So I can press M over here and select kernel 32. Okay, so we have our first API resolution, or may I say module resolution. And so let's go and mark this MW resolve kernel 32 DLL. Okay, and this is the address of kernel 32 DLL. So MW ADDR kernel 32 DLL, or let me just say handle kernel 32 DLL. Okay, let me go back. Let me go into the second one, and looks like this is the same function 821C. So I can rename this as MW underscore resolve module handle, or let's just say that MW underscore get module handle. Okay, let's go back here. Let's come inside here. We have another hash, as I said over here. Press M here. It does not find the enum, so that's fine. Right click here, hashdb hunt algorithm. This is the same one, CRC32. Press OK. Right click here, hashdb lookup. and it says that this hash was found, which is ntdll.dll. Press M over here and select ntdll.dll. Okay, and I will rename this as well, and mw underscore handle ntdll dll. Okay, and this function would be mw underscore resolve nt. Okay, it's fine. Now we have our next function. In this next function, if we go down, we are seeing some hashes, and then we are also seeing that the handle of ntdll.dll is being used. So this looks like it is resolving the NT level APIs. This function is quite large. I will show you how I resolve these APIs and rename them. And then I will go through that quickly, and I will fast forward till I complete this renaming of the functions here. So let me do the first couple. Press H over here to convert this to hex. Then right click here, hash db lookup. And the hash is matching NT allocate virtual memory. I will say import. All right. And then I will press M over here. So NT allocate virtual memory. After that, I will copy this name. And what is going on here is that these two things are going to be passed into a function which is down here. This function. And from here, this keyword, which you see as the third value. So 1, 2, 3, every third value is going to be the address of this function, this dynamic API. So I will rename this as the address of this function. So n here, mw underscore addr, and I will say nt allocate virtual memory. Okay, I will show you one more. Press H over here, press M over here, RTL get version. I will copy this name. And I will rename this as well, mw underscore addr. Okay, and now I will continue to do this for all the functions here, and I will fast forward through this, and I will resume the video after this is completed. All right, so I have completed the renaming of the dynamic APIs resolved in this function, and I will rename this function as well, nmw resolve nt API, and we'll go back. We'll go to the next function. This is now going to be resolving the kernel 32 API. We can look at this here. I will do a couple by hand, and then I will fast forward the renaming of these APIs as well. So I pressed H over here to convert this to hex. Press M over here. The enum is not there, so I will right click here and say hash db lookup. It says that it is the virtual alloc API. I will select kernel 32 in this drop down. say import, and now the APIs should be imported. It says 1359 hashes added for module kernel 32. And now if I press M over here, virtual alloc API is now there. I will copy this name and I will rename this address to this API. Let me do another one. Press H, press M. This is virtual free. Copy this name again and MW underscore ADDR virtual free. So let me fast forward and complete this, and I will see you after I've completed the renaming of this APIs.
One eternity later.
All right, so I have completed the renaming of the Windows API calls that are dynamically resolved in this function. This is a function which is resolving the kernel 32 APIs, and in the middle there are some NTDLL APIs as well. But generally, this is resolving the kernel 32 APIs. So I will mark this as so nmw underscore resolve kernel 32 API. The next function is also going to resolve some APIs. So H to convert this to hash, right click here, hash db lookup. And this is the hash of user32 DLL. I will press M over here and select user32 DLL. Then I will press H here, right click, hash db lookup. This is wininet.dll. I'll press M here and say wininet. So this is going to be the handle of user32 DLL. And this is going to be the handle of wininet DLL. Press H here again, press M, it is not there, right click, hash db lookup. This is shell32 DLL, press M, shell32, press H here, lookup, press M. So I will go through and rename the hashes and the resolved values over here. I will fast forward this again and I will continue after we have completed the renaming of these values.
A few moments later.
All right. So for this last one, there was no match found. So I will leave this as it is, and we will come back to it if we are not able to understand what it is. So I will rename this function to mw underscore resolve module handles. And let's go outside. We have another function over here. And it looks like there is the resolution of the APIs continued over here, but here we can see that multiple DLLs are being used and multiple APIs are being resolved. I will show you how I handle the first one. It is not there, so I will press no, right click, hash db lookup, user32.dll import, and I will just say M here, message box A, copy this. So I will continue resolving these APIs and renaming them properly, and I will resume after this is completed.
A few inches later.
All right, so I have completed the renaming of the resolved APIs in this function as well. Let me rename this function, and this function is going to be mw underscore resolve miscellaneous APIs. Let's go out, and this is the last function in this whole function. Let's look here and we can see some more APIs being resolved here. Let me convert this and let me do a lookup, import, and let me rename this as well. All right. So the API renaming in this function is also complete. It is resolving the OLE32 API. So let me rename this function NW underscore resolve OLE32 API. Go outside. And we can see that this whole function, which is 6298, is resolving either the module handles or the APIs. So let me rename this function specifically resolve handles and APIs. Okay. So let's go out. And now if we go down, we can see a lot of information related to what's going on here. There is some great information which we can try to understand from the data that we can see here. For example, if I use one of my favorite malware analysis techniques, which is API pivoting, we can see here that a mutex is being created. Now, if you look at create mutex w API, copy this, and I will go to MSDN to look for this API. We will see something interesting here. There is LP security attributes being passed here. There is a Boolean being passed here. And then there is a string also being passed over here. If we go back, we can see that v9 is being used in this function create mutex w. It is being used here, and it is being used in this function as an argument as well. And before that, we only see the initialization of v9. v9 is not being modified here, and v9 is being used here. So it is safe to assume that the modification is taking place here. Now, if you look at the second argument to this function, we will see that this looks like some sort of encrypted data. Okay. So going into this function, we have an idea that this is some encrypted data, and this is supposed to be a string. So we can assume that this is a string decryption function. So this is encrypted data, and this is possibly decrypted data, and this is possibly a string decryption function. Let us go down and further check what is going on in this function. We have two XOR related calls here. One is here and one is here. Now, I have looked at this code before, and this is in fact a string decryption function. That brings us very nicely to the string decryption flow explanation. And here I have created a small flow chart to explain how the string decryption is taking place. There are two arguments to this function. The first argument is the encrypted data, and the second argument is going to be the decrypted string. The decrypted string length is calculated first, and it is the first byte XORed with the fifth byte. Okay, and it is here, this one. The first byte is this one. It is XORed with the fifth byte. Okay, if we go back here, if we look at this data, and I want to remove the synchronization here. Okay, so the first byte is 20, 0, 1, 2, 3, 4. So this is XORed with 30 to get the length of the decrypted data. If we go to our terminal and launch Python, and we say 0x 0x20 XOR with 0x30. So 16 is the number in this specific case. Okay, let's go back. Next up, what happens is the key is calculated. The key is the value of the first byte of the encrypted string. So key is the first byte of the encrypted string. Next up, the encrypted string start index is the first byte index plus 6. This one here. Encrypted data start, first byte plus 6. Okay. The decrypted character is the encrypted byte. So the encrypted byte. So obviously this is in a loop, which means that the encrypted data start will is going to be used to calculate the encrypted byte, and every time this gets into the loop, I will be incremented and the characters will move forward. Okay, so the encrypted byte at the start of this loop is going to be the data start. All right, and the decrypted byte is going to be the encrypted byte XORed with the key, this one here. Encrypted byte is equal to the value at the encrypted string start index plus 1. Okay, the encrypted byte is the value at the encrypted string start index plus 1. So this one here, actually this is not plus 1, it should be plus I. This one is not plus 1, this is plus I, and this is key is equal to key plus 1, this function mw increment value. We are going to look at this in IDA Pro as well. Okay, and at this point there is a decision point. In the decision point, it is checked at this part whether I is less than the decrypted string length. Okay, if it is less than the decrypted string length, then this loop keeps on going, otherwise it exits. Okay, so here let's go inside this function and let's rename the arguments to understand what is going on here. And mw underscore, sorry, it's going to be arg underscore encrypted string. Let me just make this a bit smaller so we can see a bit more here. mw underscore, sorry, arg underscore decrypted string. Okay, now let's look at this function. This function is just incrementing the value that is passed to it. Okay, so let's say mw underscore increment value. All right, and this one, this thing is going to be what? It is going to be the thing that we looked at here is the key byte. So this is going to be var underscore key byte. So the key is going to start at the start of the encrypted string. Then we have the loop count or the decrypted string length. So here we can say var underscore loop count. Okay, and here we have the start of the encrypted string, so we can say var underscore start encrypted data. Okay, and we have current var underscore current byte. So the decrypted string is going to be calculated by the key byte XORed with the current encrypted byte. And each time this loop moves forward, the next character is going to be set up in the decrypted string. And finally, the decrypted string is being returned by this function. Let's go back and let's now rename this function to mw underscore string decryption. Another thing that is going to help us understand or figure out whether this is a string decryption function is if we press X over here, we can see how many times this function is being called. Okay. Now, the next thing that we need to do here is try to find out what are the different decrypted strings calculated by this function. For that, I have written in IDA script. So here it is the IDA script. Let's go over the script. So we firstly have the address of the string decryption function. We are going to find the xrefs of the string decryption function wherever this function is being called from. Next up, we are going to get the first argument. So in this case, this argument. Okay, we are going to find out this argument of every place where this function is being called. And after we have this argument, we are going to get the bytes from that address. So from this address, we have to get the bytes. Okay, we are initially going to read 8 bytes. We are going to use that to understand how many further bytes we need to read, because we are going to use that to calculate the decrypted string length. From there, we are going to read the number of bytes required to calculate the decrypted string. And from there, we are going to calculate the decrypted string itself. So here, firstly, we see that we are going to get bytes from this address. I said 8, I think it is 6 over here. So my mistake there. So 6 characters are read initially and we get the encrypted value. And from there, we are going to send this encrypted value to our decryption function. If we go to our decryption function, we are going to initially calculate the result length. Okay. When we calculate the result length, we are then going to go and extract further data from this byte position. And after that, we are going to start calculating the decrypted data over here. Okay. After the decrypted data is calculated, so this is actually a loop. So let's recap what is happening here. We have the function address. We are going to find out each and every location where this function is being called from, and this is then stored in this list. From this list, we are going to extract the first position where this function is being called from. We are going to get the first argument address, which is this one here. After we get the first argument address, we are going to get the bytes from this address, and we are going to get into the process of decrypting the data. After we have calculated the decrypted string, we are then going to add a comment. And this comment is going to be added at the end of this line. So let's execute the script. Control A, Control C, space, Control V, space. And now it's going to go and enter the comments. So press F5. We can see the comments have been added. If I press X here, we can see all the decrypted strings here. Okay. Now, there are certain places where the strings used are going to be wide strings. And this is because a lot of these APIs where Windows accept wide char, you have to extract wide strings. For that, I have added a decryption function. And inside the decryption function, I have also checked whether this string is a wide char. So at the end of the decryption function, there is a decode string function which checks if this is a wide char, and if it's a wide char, it is treated accordingly, and after that the relevant comment is placed. I have also added extra debugs which can help you understand what is going on here. So if you see that the byte array calculated here was URLs and \x00, in some cases this is a wide char. You can see UP, so after every character you have \x00. So here the \x00 was removed and the final decrypted string was update data.dat. Okay. Now, once we have this data, we are able to move on to the next part of the final payload analysis. I'm sorry, I'll close this. The final payload analysis, which is going to be strings pivoting. Okay. So let's look at these strings here. Press X here, and we can see a lot of interesting strings here. We can see that there is some command getting executed which calls ipconfig/all. Then we have domain enumeration commands as well. These are all interesting commands, and you can double click on them to find out where they are being used and where they are being executed. We saw already that ranang was being used here in this function here, and so after it is being calculated in v9, it is being passed to this mutex function here. So it is safe to assume that this ranang string is the mutex value. Let's press X here again, and if you go down, we are going to see some other interesting things as well. So we have the user agent, and here we can see what we were looking for. These are two of the C2s that are used inside the application. What else can we see? We can see that there is this update data.dat. If you do further analysis of this application, you will see that this application copies itself to a temporary location, and then it exits the main application and starts executing from that temporary location. I think you can find this path here. It is local app data, and after that, it the value is not here, but there is a temporary place where this application is getting copied. Custom update is also part of this path. Anyways, we can now go up and look at some of the other functions that we did not analyze before. So let's start here. If we go inside here and go inside here, we can see that this function is looking for something being debugged. And if you go inside here, we can see that the current peb is being extracted. So we can say nmw underscore get the peb, and then we can say mw underscore get being debugged. Okay, and then we can see here nmw underscore is debugger present. Okay, this is the first function. And if we go here, we have another function which is part of the reconnaissance RTL get version. So this is getting the OS version, mw underscore get the Windows OS details. We go back and go here, we can see that the list of processes is being extracted. We can see create tool help 32 snapshot is being called. And if we right click here, we can't add the symbolic constant here, but if we go here and right click here, we can use standard symbolic constant. If you look for th, we can see snap process, which means that it is looking for processes here. So this is mw underscore get process list. So get OS details, get process list, get the current process is wow64 process, and this next one is getting the IP address details, get the adapter info. Okay, so and so on and so forth. You can take your time to analyze this code. Now obviously we can spend a lot of time doing the analysis, but I think we have now reached a situation where the APIs have been renamed correctly and the strings have been decrypted correctly as well. Now it's just a matter of trying to analyze this code further. I will stop here. I invite you to spend some time analyzing this code and leave your feedback in the comments as well about what you found while analyzing this code. If you face any problems as well, hit me up on Twitter or in the comments. That brings us to the end of this video. Thank you very much for your time.